Hi, Dr. Brown. So, for my little bonus project, I decided to kind of put some of the stuff that we learned in class to use at my house. Um, so I had this little drawing, little game thing that kids play with, and I have lost the pen. So I was like, okay, how does this thing work? So it turns out that like inside of it, it's iron filings, right? And it uses pretty much just uses a magnet to draw on it. And so I was like, okay, how can I do this using some of the concepts we learned in class to make a magnet? And so pretty much what I did was I got this 1.5 volt battery and this iron nail kind of thing, and wrapped around it some insulated wire many times actually. Uh, and it has to be insulated or else like the current's not going to go around it, which is what we need. And I found that out during my first trial, but but anyway, so I wrapped it around a couple times, just attach it to this battery like so, and I can use it to draw on this toy. Okay, so now about some of the concepts that govern like what we just did. This is pretty much what's happening. Let's say we have some current. Okay. Some current going in to this loop of wire, or to this coil. It comes out over here. Pretty much what happens here is there's a ton of magnetic field that is made inside this loop. And it comes out and comes around back in here. This magnetic field outside quickly weakens as you get further and further away, but that magnetic field inside of it is pretty strong, relatively speaking. So this ends up, this gives you like a north pole right here and a south pole right here because the magnetic field is leaving from there and entering at the bottom. And so like pretty much what you have here is an electromagnet because it is a magnet made from electricity. But for our purposes, this turns out like you just using a loop of or a coil of wire. It's not strong enough to do what we want it to do for practical purposes because I mean, if you turn up the voltage really high or if you make tons of loops, maybe it would be useful for us. But right now, it's not strong enough. And that is why we have to introduce the piece of iron. So here you see we have the iron introduced into that coil of wire. Pretty much what we did was we put an iron nail and looped the wire around the nail and attached the two ends to a actually we did use a 1.5 volt battery in our little demonstration. And what happens is, as a result of the magnetic field inside of that coil, the iron inside becomes magnetized as well, and that produces additional magnetic field. And this turns out to be much stronger of a magnetic field than what we would have without that iron in there. And this becomes an electromagnet that we can use for practical purposes. If we want to, draw on a little toy with, like I just did at my house. And it turns out that this also has like you know, this can be applied like at much larger scales and make much larger electromagnets, and it turns out that's what they actually use to like large scale electromagnets like this is what they use to pick up cars in junkyards and etc. etc. Further application of this is like when we use, if we wanted to use superconductors, which is not something we're going to do at our house or anything, but right now we're limited by the amount of current we can put through here. Like if we turn up the voltage too high, eventually it's going to get too hot and it's going to melt. But with a superconductor, we're not limited by that heat factor as much because there's no electrical resistance. So you're able to use much larger amounts of current and voltage and make much stronger electromagnets. And thank you. It was a great semester.